All right, we're back with some more indefinite integral problems. I'm going to do two problems right here. Both of these involve trigonometry. They're on your study guide on page 122, number 21, and number 23. So let me just find them here. There we go. All right, so here's number 21. In number 21, we are going to find the indefinite integral of -2 cosine x over 3 dx. Okay, so the first thing we want to do is we want to start by pulling out the constant. If we see the constant here is -2 over 3, so we can take this out of the integral and not worry about it until the very end. And that will allow us to focus on the trig function inside, which is cosine x dx. Okay, and so now what we need to do is simply to find the antiderivative of cosine x. With the antiderivative, what we're looking for is the function whose derivative is cosine. That would be the antiderivative. And of course, the derivative of sine is cosine, and so the antiderivative of cosine is sine x plus a constant. Don't forget the constant. And so we can clean this up a little bit and we get -2 over 3 sine x plus a constant. Okay, now we've already talked a lot about why we don't need to write -2/3 c. I won't get into that, but what I do want to do is take this answer. This is the correct answer. We want to take this answer and check to make sure it's the correct answer. We can check to see that it's correct by taking the derivative of our answer. In other words, the derivative of -2 over 3 sine x plus c. And when we find, since we're calling this the antiderivative, if we take the derivative of the antiderivative, what we should get is the function that we started with. We should end up with -2 over 3 cosine x. So let's just do that. Again, with derivatives, the same as with integrals, we can take this constant multiple and pull it out. So we would have here -2 over 3 times the derivative of sine x plus c, and the derivative of sine x plus c, of course, is cosine x, and the derivative of a constant is 0. And so we can see that this is the correct answer because we get back the original function that we started with, -2 cosine x over 3. Okay, that was a pretty straightforward and simple problem. Let's do one that's a little bit more complicated here. We have in problem number 23, looking for the antiderivative of 4 cosine x minus 9 sine x dx. Don't forget the dx, got to be there. Okay, let's see. To start off, we need to, we can separate these into two separate integrals, and at the same time we'll pull this constant multiple out. We should have done this enough times that we should be able to do this with relative ease. Take the constant out. 4 times the integral of cosine x dx minus, and make another integral, pull the 9 out, minus 9 times integral of sine x dx. Okay, and so now we can concentrate on the antiderivative, the integral of cosine x dx. We have 4 is the constant, and the antiderivative of cosine x is sine x. You can check by finding or thinking about what's the derivative of sine x. It's cosine x. So this is the correct antiderivative. Minus 9 times, now the antiderivative of sine x, the integral of sine x, is negative cosine x. plus c. Let's do the same thing here. Cover this up. The integral of sine x is negative cosine x. You can check that. It's because the derivative of negative cosine x is positive sine x. And there we have it. We can multiply these together. We get 4 sine x. Minus 9 times minus 1, this will be plus 9 cosine x plus c. Let's just quickly, this is our answer. Let's quickly check this by differentiating. The derivative of 4 sine x plus 9 cosine x plus c. We can find the derivative of each of these terms separately. 4 is a constant multiple. We pull that out and multiply times the derivative of sine x. The derivative of sine x is cosine x plus 9 times the derivative of cosine. The derivative of cosine is minus sine x. And the derivative of a constant is 0. And so here we get 4 cosine x minus 9 sine x, which is indeed the function that we started with right here, which means that this is the correct answer.